Alright, Chapter 3. This is where we get a better understanding on Producer and start writing actual code. We're going to learn how to produce messages to Kafka, and more importantly, how to do it reliably and efficiently. Before we write a single line of code, let me walk you through what happens when you send a message. Step 1. You create a producer record with a topic, key, and value. Step 2. The serializer converts your key and value into byte arrays. Kafka only deals in bytes. Step 3. The partitioner decides which partition this message goes to, using the key hash or round robin. Step 4. The record lands in a batch, a buffer of messages destined for the same topic partition. Step 5. A separate I/O thread picks up full batches and sends them to brokers over the network. Step 6. The broker writes the message and responds, either with record metadata on success or an error. This architecture separates I want to send from the actual network I/O, and batching gives you throughput. You have 3 choices for sending, each with different trade-offs. Fire and forget, call send, and move on. No result check. This is the fastest approach, but you may lose messages silently. Only acceptable for non-critical data, like debug logs. Synchronous, call send.get. This blocks your thread until the broker responds. You know immediately if it worked or failed. Reliable, but slow. 1 network round trip per message kills throughput. Asynchronous, call send, with a callback function. The callback fires when the response arrives. This is the sweet spot for most applications. High throughput because you're not blocking, but you still handle errors properly in the callback. Now let's look at the key producer configs for Apache Kafka. Ax controls durability. Ax equals 0. Right pointing arrow, no acknowledgement. Fastest, unsafe. Ax equals 1. Right pointing arrow, leader only. Default. Ax equals all. Right pointing arrow, all in sync replicas. Safest, slowest. Linger.ms controls batching delay. Default is 0. Send immediately. Setting approximately 5 to 20 milliseconds lets Kafka batch more messages, improving throughput at a small latency cost. Batch.size sets max batch bytes, default approximately 16 kilobytes. Larger batches improve efficiency. Enable.idempotence should almost always be true. It prevents duplicate messages during retries with minimal overhead. Compression.type reduces network and disk usage, none. gzip, snappy, LZ4, ZSTD. In practice, LZ4 or ZSTD gives the best balance of speed and compression. Kafka needs byte arrays. How you convert objects to bytes matters. On the left, built-in serializers, string serializer, integer serializer, byte array serializer. Fine for simple cases, but limited. On the right, Apache Avro, and this is what I strongly recommend. Avro gives you schema evolution support. Your data format will change over time. Fields added, removed, types changed. Avro handles this gracefully. The schema lives in a schema registry, and each message just carries a schema ID. Consumers can read messages written with older schemas without breaking. The bottom line, Avro plus schema registry equals safe schema evolution without breaking consumers. The partitioner decides where each message goes. The default partitioner. If a key is present, it hashes the key with murmur2 and mods by partition count. Same key always goes to the same partition, giving you ordering guarantees. No key? The sticky partitioner fills 1 batch for a random partition, then switches. This produces larger, more efficient batches. Custom partitioners. Implement the partitioner interface when you have business logic for routing. Maybe VIP customers go to a dedicated partition for priority processing. You get full control over placement. Here's my recommended production configuration. Ax equals all enable.idempotence equals true linger.ms between 5 and 20, compression set to LZ4 or ZSTD, and Avro serialization with schema registry. Use async send with callbacks. That gives you the best combination of throughput and error handling. Now, let's review. Question 1. What does enable? Idempotence equals true prevent. Answer. It prevents duplicate messages caused by producer retries. Each message gets a sequence number, and brokers use it to detect and skip duplicates. Review question 2. Why might messages arrive out of order within a partition? Answer. With max.in.flight.requests, greater than 1, if batch 1 fails and retries while batch 2 succeeds, they arrive out of order. Enabling idempotence fixes this by using sequence numbers to restore order. Next up, Chapter 4, where we flip to the consumer side. See you there.